Hey guys, so here we are with 6.5, properties of logarithms. So we've already looked at what logarithms are, that they are the inverses of exponential functions, that they are equal to exponents. So when we're trying to calculate a logarithm, we're trying to find the exponent that we would raise the base to give us the number. So in this lesson, what we're going to be looking at is the properties of the logarithms. Just like with exponents, there's properties of exponents, there's also properties of logarithms. So we're going to use the properties of logarithms to evaluate some logarithms. We're going to use them to expand and condense log expressions or logarithmic expressions. And there's also, we're going to use this change of base formula as well to evaluate logarithms. Evaluate means, again, just calculate. We're calculating logarithms with a change of base formula. We use the calculator for that. All right, but first let's go on to a cartoon. This is one of my favorite cartoons, and it actually took me a little while to find this one. But here you are. Pigeons up there on top are saying, "Hey, you thinking what I'm thinking?" That makes me laugh. Okay, so let's jump into the properties of logarithms and see what these are. Okay, so up top it says, you know that the logarithmic function with base b is the inverse function of the exponential function with base b. So we've already talked about that. They have to have the same base to be the inverses. Because of this relationship, it makes sense that logarithms have properties similar to properties of exponents. Okay, so let's kind of look at these one at a time. There's three properties of these logarithms: the product property, the quotient property, the power property, and we saw the same kind of thing happening with the exponents. So I'm going to kind of side by side compare the exponent properties to these logarithmic properties. So here's our properties of exponents on the side. You probably want to write this on page 176, just right next to each one so you can see them just side by side compared to each other. So we know the first property with the exponents that we usually saw was when we were multiplying with the same base. And this was the product property of exponents. So when you have the same base, you can add the exponents. So we're going to be just giving it to one base and then adding the exponents there on that property as the product property there. Look at the one for logarithms here. So if you have a log with base b of m times n, okay, so you're multiplying m and n, so you're multiplying it right here. So you're saying our product, we're multiplying here. We're multiplying here with this part, m times n. It's going to equal the logs added to each other. So each one gets its own log base b of m, log base b of n, and we add them together, kind of similar to what we have here with adding the exponents. Okay, so that's what we're doing on that one. Because remember, logarithms are exponents, right? So this log base b of m, it would be an exponent plus the other exponent of log base b of m. So they are exponents. Like adding the exponents here, we're adding the exponents here, but in just a log kind of form. Quotient property, the one for the exponents, we could see here was base b to the m over base b to the m. We subtracted the exponents on that one. So the quotient property here is the same thing. You have m over n here, where we're going to subtract the logs then. And so it's going to be log base b of m minus log base b of n. We're subtracting the exponents. Each of these are an exponent, so we're subtracting those here. And then the power property, this last one in the exponents, was a power to a power, so a base b to the m raised to the n power. We were multiplying those powers to each other. In this case, if we have a m to an n power, then what we would do is we're going to say that this power right here is going to multiply this exponent here. So you have an exponent n. Log base b of m is also an exponent. So you're going to be multiplying the powers basically in log form. So n times the log base b of m. So those will be multiplied to each other. Now, one thing to keep in mind, and we don't usually do this with exponents, is in this one we can go backwards. So if we're shown this right here, if it's got log base b of m plus log base b of n, we can then put it back into this form, which would be considered condensing it. So from going from this direction to this direction, going from this part right here on the left to the one on the right, that's expanding. We're expanding it out, making it bigger, longer. If we go from this part back over to here, we're called condensing it. We're going to condense it down into just a single logarithm. So this is a single logarithm. This is an expanded with several logarithms in it. And so we would sometimes condense, sometimes expand using these properties. Okay, so if you go to page 177, our extra practice here, it says in exercise 1 through 4, we're going to use these two logarithms. Log base 2 of 5 is equal to this decimal, log base 2 of 12 is this decimal, to evaluate the logarithm. So they're giving us what these logarithms are, approximately to this decimal place, 3 decimal places. Remember, on the calculator, we can only right now calculate the common log, that's log base 10, or the natural log base e. These are log base 2s, so we're not going to be able to get this from the calculator right now by plugging it in. So they have to give us these calculations, and then we can then calculate logarithms using these calculations. So number 1, what we want to try to figure out here is we have a log base 2, and that's what they all are. They're all log base 2s. But of this number part, we want to figure out, okay, what can we do with 5 and 12 to be able to get to 60 somehow? So we're trying to use 5 or 12 or both of those numbers to get to a 60. And this one, you just can multiply 5 times 12 and it would equal 60. So we're going to do that. We're just going to say 5 times 12 there is the 60. And so now this would be a product property. So we're going to use our properties here. So we have a product here going on. So now we're going to break this into 2 logarithms, one with 5 and one with 12. And so now it's going to be log base 2 of 5 plus log base 2 of 12. Remember, the product property is always adding the 2 logs together. Product, you're adding. The quotient, you are subtracting. And so in this one, we're going to see, we can now calculate what these are. We know what these are. We just plug in these numbers here. For this first one, we're going to plug in that number, 2.322. And the other one, it's going to be the 3.585. And then we just add them together. You can use a calculator to add them together real easily. It's 5.907. So that's what log base 2 of 60 would equal using our properties and using these calculations that they give us. Now, number 2, we have a 1 over 44. So again, we want to try to figure out how can we use either 5 or 12 or both of them. Well, we only need to really use 12 because 12 squared, or 12 times 12, is 144. So we can kind of think of it as 1 over 12 squared. And so now at the bottom we have a 12 squared, and now we have a quotient as well. We have a fraction. So we have 2 things we need to work on. One, the fraction, we can deal with that first. So we can now say, okay, it's log base 2 of the numerator minus, we're going to subtract when it's the fraction here. If you remember, they sound the same, subtraction and fraction. So fraction becomes subtraction, or subtraction becomes a fraction. So kind of keep that in mind. And then the other one's going to be log base 2 of the denominator. So log base 2 of that denominator, 12 squared. And now we have a power product, or a power property right here with the 12 squared. So what we're going to do here is we're going to take the exponent and put it in front of the log, so we can multiply 2 times the logarithm just on that part. So that first part stays the same, log base 2 of 1. Now it's minus 2 times the log of log base 2 of 12. Well, now log base 2 of 1, this is one that we've already looked at before. It's one of those always logs. If this is 1, we always know what the answer is, because 2 to what power would give you 1, and that's got to be 0. So this would be one of those always logs. Whenever your number part here is 1, it will equal 0. Okay, that's just knowing that we know 2 to what power, 2 to the 0 power is going to equal 1. So that's why that logarithm has to equal 0. This one, we're going to say 2 times this decimal number, now that we have the decimal up there. So 2 times that 3.585. And then we just can go ahead and figure out that's going to be negative 7.17. So we don't really need the 0 anymore, just multiply negative 2 times that to give us the negative 7.17. So we have another fraction here, which will become a subtraction. That's the quotient property of the logarithms. So these are going to be subtracted. The log base 2 of 12 will subtract the 1 for 25. So the numerator is always going to be first. So log base 2 of 12. But first of all, we see we do have a 12, but 25 we want to see as 5 squared because we got to use 5. So we got to realize we're going to break that 25 down into a 5 squared. Do that part first. Now we'll make it into the subtraction. So our numerator is going to go first, log base 2 of 12 minus log base 2 of the denominator. That's the 5 squared. And now we're going to do the same thing here as we did over here when we saw 12 squared. 2 is going to go in front of our log. And so our first part will stay the same, log base 2 of 12 minus, and now it's going to say 2 times the log base 2 of 5. So now we know these decimals again from up here. So we're going to just plug in our decimals. So the first one's at 3.585 number, minus 2 times 2.322. So we want to multiply this inside here first, 2 times that. So our first number is going to stay the same, 3.585. Now it's minus 4.644 when we multiply by 2. And then when we just subtract that, we're going to get a negative number, negative 1.059. So all that's just going to do on the calculator with the decimals if you want to. And then we come over to number 4, 720s. That might be the harder one to think of. We got to use somehow use 5 and 12 or both to figure out how to get to a 720. Well, if we think about, remember 60 was 5 times 12, and if you multiply 6 times 12, that's 72. So that might help. So it's like 60 times 12 would give you 720. So we could think of it as a 5 times 12 times 12, or 5 times 12 squared. So I start off with the 60 there. And since we already knew, actually, we already know what 60 is. We know 60 is this number, 5.907. So since I already knew that, I don't have to do 12 squared, in fact. I can just do 12 times 60, since I already have that decimal over here on number 1. And I can use that. And so we're going to do the product property where it's going to be addition. So our first log of the 12 plus the second log. And this one doesn't matter the order you put them in. We could have put the 60 first and the 12 second. But with the fractions, the numerator always has to go first. The denominator is always going to have to go second. So now we know what this decimal is here. That's the 3.585. We also know what this decimal is here. That's the number we got from number 1, 5.907. And then we can just add those together to get our answer, 9.492. Okay. All right, we're going to go on to doing some condensing and some expanding now with the logarithms using these properties. Okay, so 5 to 8, here it says expand the logarithmic expression. We're going to use our properties to now make this single logarithm into kind of more than one logarithm. We're going to expand it out using those properties. So here's where we got to see a product property. We're going to put plus. If it's a fraction, we're going to make it subtraction. And any powers we got to put in front of the logs to multiply the logarithm. So here on number 5, log 10x, well 10x is 10 times x, so that's a multiplying situation right here. We do see this would be base 10, right? So we know this is a common logarithm. That would be base 10. We don't need to put the 10, we can just keep it as log. I put there just a 10 just to show you, remind you that is base 10. So we have log base 10 of 10 plus log base 10, or log of x. Now here's where we see log base 10 of 10. Here's another one of those always logs, that if the base and the number part are the same thing, that will always equal 1, because 10 to what power will equal 10? That'll always be 1. So when these numbers are the same, we know that's going to equal 1. And so it's 1 plus log x, and that's it. That's our answer. So it's expanded to this. So this logarithm expanded to 1 plus log x. Next one, number 6, ln, again, that's base e. On this one, log base e, and we have a 2 times x to the 6, so another product property kind of similar to this. We're going to see a plus on this one as well. So put it into 2 logarithms where we have the natural log 2 plus the natural log of x to the 6th. So they're just going to break apart the 2 times x to the 6th, but now we see an exponent here on x to the 6th. This is a power property where we got to put the 6 now in front of the log, so our log 2 will stay the same, plus we're going to put the 6 now in front of the log, and now going to say 6 natural log of x. So 6 times the natural log of x. So there's our final expansion right there of this natural log to x to the 6 becomes this. So here we see a fraction on number 7. We got to think about that's the quotient property giving us a subtraction. So we're going to be putting this out into 2 logs, but we're going to be subtracting them, numerator minus the denominator. So start off with log base 3 of the numerator minus log base 3 of the denominator. We can start there. So there's log base 3 of the numerator minus, and then log base 3 of the denominator. And now in each of these we see there's some things to do. So like on this first one we have a power of 4. That 4 is to the power property. 4 is going to have to go in front of the logarithm. 4 times our log, because remember it's like power of a power is you multiply those exponents. So we have an exponent of 4. This log base 3 of x is also considered an exponent, so it's like two exponents multiplying each other. On this one we have a product actually and then a power. So we want to deal with the product first. So 3 times this y to the third. So let's first work on this. I'm going to leave that for now just as the same. We will put that 4 in front on the next step, but I want to expand this one out a little bit further to have, it's going to be minus log base 3 of the first one plus log base 3 of the second one. But because it's a minus here, here's where it can get a little tricky. Because we're subtracting this entire logarithm, we got to put that in a parenthesis. So we got to put this kind of product part in a parenthesis here. So minus the parenthesis of log base 3 of 3 plus log base 3 of the y to the third. That way we're going to have to distribute the negative. The negative will affect both of these, making both of them into negatives. So here now we're going to do our powers, put the 4 in front of this log. So 4 goes in front of that one, 4 times log base 3 of x. This is now going to be minus this part here. So minus the log base 3 of 3. And now this minus times positive becomes a minus as well. So minus the last part, log base 3 of y. But we have this 3 here. We're going to put that 3 also in front of this log. So it's going to be 3 times log base 3 of y. So that goes in front. So 3 times log base 3 of y. The only thing we could do last here, and I didn't do it, but we could change this right here, log base 3 of 3, into 1. And we might want to do that on this one, but we could change that into a 1 if we needed to. But I just left it like that on this one. Number 8. We have a root sign in here, a fourth root. So the first thing we want to do is always, whenever you see roots anywhere, you want to change it back to a fraction exponent. So this would be 4 is the denominator of our exponent. There is no extra exponent, so 1 is the numerator. So that's the same thing as saying the natural log of the 3y squared raised to a 1/4 power. Okay, so now since the power is outside this whole thing, we do have a product inside, but the power is going to come first. We're going to have to put this power out in front of this log first before we can start working on this product of the 3y squared. So I'm going to first put that 1/4 in front of this whole natural logarithm. So now it's 1/4 times the natural log of 3y squared. Now I can make my product here and do the adding the two logs. So I have a natural log of the 3, natural log of y squared. But 1/4 has to go into front of both of those natural logarithms because the 1/4 is affecting both 3 and the y squared. So it's going to be 1/4 in front of the first one. So 1/4 natural log of 3 plus, then it's going to be 1/4 in front of the natural log of the y squared. So 1/4 natural log y squared. Now the last thing to do is we do have a power property here, y squared. We're going to put that 2. We're going to multiply this 1/4 that's already in front by 2 as we put it in front here. So this one's all done here in front. We can put that in our answer. 1/4 natural log of 3. But then I'm going to have to multiply 2 times 1/4, which would be 2/4, and that would simplify to 1/2. So it's plus 1/2 natural log of y. So as you put the 2 in front, 2 times the 1/4 would give you a 1/2. Alright, so next part is going to now do the opposite. We're going to be now going from this back to a single logarithm called condensing. But first, let's do a little joke of the day. How many tickles does it take to make an octopus laugh? 10 tickles. 10 tickles, tentacles. Okay, so back to the extra practice, 9 to 13. We're condensing the logarithmic expression. So we're going to take this bigger log expression and condense it down to a single log of the base it gives us. So this first one, number 9, base 2, we're going to condense it down to one single logarithm using those properties. So if we see the plus here, that means we need to multiply the 3 and the 8 together to condense it down. So we can write one single log of base 2 with 3 times 8 in the number spot. So 3 times 8 would just be 24. So the answer for that would just be log base 2 of 24. Number 10, here we got a subtraction sign. So with that one, we're going to need to make it into a fraction. So the first one here, the 4, we'll make this a log base 5 first. But 4 is going to be the numerator. and then this part will be the denominator. But before we can do that, notice that this next one, the second one, has a 2 in front of the logarithm. So whenever you have a number multiplying the log, you got to put that back up top as a power. So the first thing we're going to do is just write this first one. We can't do anything with this yet. So log base 5 of 4 still here. We got to move this 2 back up to the top here. It's 5 squared. So now it's minus, so that's what I'm showing you. That's going to go back up here. So minus log base 5 of 5 squared now. So now we can make our fraction out of the 4 and the 5 squared. So we have log base 5 of 4 over 5 squared, which is just 25. We wouldn't want to leave it with 5 squared at the bottom. We would just make that a 25. So log base 5 of 4/25 would be our answer. On the next one, we see a 3 in front, so that's kind of what you want to look for first. Do you see any of those power properties where you could put the number back up as a power for this part here? So 3 is going to go back up here, but here's where you notice there's a 6x here. If you just put 3 here and not a parenthesis, it would only be affecting the x. We want to affect the whole thing, the 6x, so we're going to put the 3 back up and put the 6x in a parenthesis. So 3 is going to go back up there. And so it's now the natural log of the 6x in a parenthesis to that third power, and then plus this part, that stays the same for now. So at this point we can now multiply our 6x here to the third times this 4y, so we can put it into one single logarithm. And as we do that, we're going to want to figure out what is 6x to the third power actually. So 6 to the third power is 216, x to the third plus this part means we're going to multiply this by our 4y, so times 4y inside that. So we want to now multiply 216 times 4. We can multiply those numbers, and then our variables here will be an x to the third with a y next to it, and that's going to be our answer. So the natural log of 864, that's the 216 times 4 with the x to the third y just at the end of that. So that's what our final answer for condensing this down to a single logarithm is. So the first thing to do is make sure you do the power property. Any power property has got to go first. So if you have a power, do that one first, and then you're going to go ahead and do the condensing down into a single logarithm with the product property or the quotient property like we see on this one. Subtraction signs will always become a fraction. The additions you're going to multiply. But make sure you do an exponent part here first. So this would be kind of like an order of operations to make sure you do this part before you actually multiply. So do the 6x to the third part first, then you can multiply those two things. All right, coming down to number 12. So we have 3 logarithms now. And if you look for any powers, there is one here with the 1/3. So this 1/3 has to go back up here as an exponent. So that's 27 to the 1/3 power. So we're going to just write those first two just the way they are. We can't do anything with those yet because we got to deal with this last one with the power first. So as 1/3 goes back up there as the power, that's the same thing as saying 27 to a 1/3 power, which we need to realize is the cube root of 27. So we want to know what number that is. 27 to the 1/3 power is the same as the cube root of 27, which does equal 3. So now we can just say for here plus a log base 2 of 3. So that's what we see there now. So we're trying to condense it down and simplify it as small as we can. So we don't want to leave a fraction exponent there. We want to change it back to what number really is that, and that would be 3 on this one. Now we can go across kind of left to right and just start to put these together. Subtraction will become a fraction. So starting with these first two, and you would just do it left to right. It's not that addition is always going to come before subtraction. It goes left to right, just like kind of order operations does that as well, left to right. So 625 over 125, we can simplify those numbers. And then we're going to put our plus this log base 2 of 3 next to it right now. So as we simplify these numbers down, it'll be log base 2 of 5, which this is a 5. So this number is 5 here. We're just now going to multiply with the plus. 5 times 3. So 5 times 3 now would be 15. So our answer for this one is the log base 2 of 15. That's putting it back into a single logarithm. So as you saw here, I kind of jumped a little bit of a step, I think, with this 625 over 125. that really is 5 here. We need to realize that this is 5, so that we're going to multiply that times 3. So that's 5 times 3 here, giving us the 15. All right, number 13, you start off with a negative sign. So when we see that, the first thing we want to do is actually factor out the negative sign from all of these. We don't want to work with a negative in front of our expression. And also we're going to look for any powers. So there's only a power here on the last one with the 2. 2 is going to go back up here. We are going to put the 3x in a parenthesis. Now what you might want to realize though is that and you might notice this, log base 6 of 6, that is the same thing as saying 1. So this problem actually could have started out with negative 1, then minus this. It didn't have to give us log base 6 of 6. It's helpful that they did though, but they could have said negative 1 right here, and we would have had to realize we're in base 6. 1 would have to be log base 6 of 6. So as we need it to be the same base, the number would have to be 6 in order for that to be a 1. So just realize that that could possibly happen. You have to actually get the log base 6 of 6 yourself. So now as we do this, we're going to factor out a negative, so the negative outside of the parenthesis. Now this is a positive log base 6 of 6. We're going to leave it there. We're not going to change it to 1 because we're condensing it down. We need this right now. And then the other sign is going to change to its opposite. So all the signs will change to their opposites. It's going to be plus log base 6 of the 2y. And then this one will be a minus, but we're going to put the 2 back up there as an exponent. So minus, sign for that, and then log base 6 of 3x in a parenthesis to the second power, and then close the big parenthesis here. Okay, so now as we kind of put these together, we can see with this, we're going to go left to right, so we're going to do the multiplication first. Addition is always multiplication, so 6 times the 2y. To put these into one logarithm with log base 6, we've got to multiply 6 times 2y, that's the product property. Well, 6 times 2y is 12y, so it's now going to have that negative out in front. Log base 6 of a 12y, and then minus this here. But as we kind of do that, we could figure out what 3x to the second power is, or do it later. So it just depends. I did it right now, so I just said 3 squared is 9, so 9x squared is what that is. And so now it's a subtraction, so now we're going to make this into a fraction inside of here. So 12y will be on the top, 9x squared will be on the bottom. So it's going to be negative log base 6 of this 12y on top, 9x squared on the bottom. The only thing we can do now is 12 and 9 can reduce. We can reduce that fraction a little bit. 3 goes into both of those numbers, so we can make it into log base 6, or negative log base 6, 4y over 3x squared. That's the best simplification for this one. So that's our answer on this one, because these two can reduce by 3, giving us 4 over 3 here in front. Okay, so on page 176, we see this other core concept that says change of base formula. You want to go there and look at that. And you want to write these arrows on here, and I'll explain what I'm doing with these. Basically, here's how we can evaluate or calculate a logarithm of any base. So right now on the calculator, we know we have log base 10 and the log base e, the natural logarithm. And we can calculate those logarithms. But what about if we had log base 2 of some other number? How do we calculate that on the calculator? Well, we can do it with this change of base formula. And how we do that is we make our logarithm. So here's a log base c of a. So c is not 10, it's not e, so it's some other base other than those. And then a could be any number there, so these numbers could be anything except this c is not going to be 10 or it's not going to be an e. And what we would do there is we would put this into a fraction form, and we're going to put it to any log we want to, so we can change this into any logarithm we want to. The b's are the same here. So just a is going to go on the top and the c will go on the bottom. So it'll be log base b of a over log base b of c. And so what I mean by that is this. We could do this. So let me show you maybe an example of that. If we had, let's just say, log base 2 right there of 3. So 2 to what power gives me a 3? We don't know. We can't calculate this without the calculator. We can't calculate it on the calculator right now. So what we can do is we can change this into the log of any base. So up on top here, I can give any base I want to. So I'm just going to put log over log right now. I can give this any base I want to. I can make it base 10 if I want to. That way I can calculate it on the calculator. 3 is going to go in the top for the numerator. 2 will go on the bottom for the denominator. And now on the top I can calculate this on the calculator. I just hit the log button in 3 to give me my numerator number, log button in 2 to give me my denominator number, and then divide that. And that's all we have to do. So this could be any base. The base b here could be the natural logarithm base, base e, or if we want to get some other logarithm base, we don't usually do that because we usually use either 10 here or base e so that we can calculate this on the calculator. Okay, so on page 178 for the extra practice 14 to 17, we're going to use this change of base formula to evaluate these logarithms. And so remember, as we do this, we're going to make this into fractions here. The 17 is going to be the numerator, the 3 will be the denominator. So this is what I always think of. This one's going to go up on the top, this one's going to go to the bottom on the fraction. So as we kind of put those in our fraction there, it's going to be log 17. I'm going to just say log as far as log base 10, so we can use the log button on the calculator. So we can say log 17 over log 3. So now we just want to calculate these, what log 17 is. And so here's what we can do. So we go to our calculator, and you might want to get your calculator out because you'll want to do some of these. I'm going to do 14 here, and then you can try 15, 16, and 17 on your own. And then I'll show you what they should be. Here's how we would calculate this. So I would hit, on this calculator, I got to hit the number first, then the log button. The calculators that we have in class, those Texas Instrument ones, you have to hit the log button, then the number. So sometimes you do it one way, sometimes you do it the other. So when I hit 17 and then hit the log button, which is down here, it gives me this decimal. So 1.23 and so on. So that's going to be right there, 1.230, I'll just say. Okay. What I could do now, I could actually hit divided by, so hit my slash here for divided by on this calculator, and then type in the log 3. So I hit 3 and then the log button, and that gives me the log for, the answer for what is log 3. It's 0.477, so that's going to go down below underneath that, so 0.477. So now all I have to do now to find out what is this top divided by the bottom, just hit equals. When I hit equals, I already have log 17 over log 3 up here, as you can see. Now I just hit equals, it gives me my number, 2.57. And we always want to go to like 3 decimal places, so we're going to round this one up to 2.579. And there it is, so 2.579. So now this is one way you can do it with the log button. We could also do the same thing with the natural log button. Let me just show you what that would be. Instead of doing log, we would just say ln. So we can do natural log of 17 over natural log of 3, and we can get the same answer here. We wouldn't get the same numbers here necessarily, but we will end up with the same result here with the 2.579. So let me just show you what that would be on the calculator here. Let me clear this, and now I'm going to hit 17 again, and this time the ln button, which is up here on the top. So ln gives me that number, 2.83, and so on. So that's that number, 2.833. And then I'm going to hit divided by again, and then 3, and then the natural log button again, the ln, and that gives me 1.098 or 97. So that's down right there, 1.099 actually I put down. Yeah, that was right, got 99. And then if I just hit equals, we should get the same number as 2.579 when I divide these two numbers. Equals, and yes we do, so there it is, 2.57 rounded to the 9. Exactly the same number as I got right here. And so that gives me the same exact thing. Actually I put 8 on this one, but I could have just put 9. I probably should have put 9. So go ahead and pause the video and then do on your own 15, 16, and 17. Just do the same thing. Use your calculator to calculate these logarithms, and then I'll show you what the answers are here in a second. Okay, so hopefully you've done 15, 16, and 17, and now you're ready to see the answers. So for 15, I'm not going to show you the calculator. I'm just going to give you what the numbers should have been. So here we should have I'm going to use natural logarithm on this one. Now you could have used the log on this one, that's fine. Your result should have been the same though. So I did natural log of this 294 over natural log of 9. If I do, though, that's 5.684 for the natural log of this, and for natural log of 9 is 2.197. So your end result, no matter whether you use the natural log or the common log, you should get 2.584. So that should be your answer. So if you use the log up here, these numbers will be different, but this number should still be the same. So if this number is the same, then you're good. But if this number is different, then you got to go back and figure out what you made a mistake on the calculator with. Number 16, we're going to put the 4/9 on the top. So I'm going to use the log on the common one on this one. So log of 4/9 over a log of 7. And so log of 4/9, we would want to put that in a parenthesis. So as I kind of put that in right there, 4 divided by 9, and then hit the log. Let me actually do that one on the calculator so you can kind of see with the 4/9 how that would have been. So I think we're going to see 4 divided by 9, and that gives you, some number here. That right there. You could then just hit the log of that, and that should give you what you have. It should give you the right number there. Let me see if that does that right there. Yeah, that's the right thing. So you could have done it that way. You could have also done it probably this way as well. If you put parenthesis, then 4 divided by 9, close parenthesis, it still gives you that. And then if you hit the log button, now you at least have that up on top of the screen with the 4/9. You might like that better. And then you can hit the divide by the 7, and then the log button again, and then equals. So that's the number at the bottom, equals our answer here. So we should have got that number at the bottom, 0.845. Our final answer should be negative 0.417. And then for 17, the 1/10 is going to go on the top, 6 is going to go on the bottom. So I'm going to use the natural log again. So 1/10, I just changed that to 0.1. It just seemed easier to put that probably in the calculator. And so the natural log of 0.1 would be negative 0.303. The natural log of 6, when I calculate that, that's 1.792. And then dividing those, the final answer should be negative 1.285. Alright, so make sure if you made any mistakes on there that you go back and you check those. Make sure you're using the calculator to check to see how you can do these. You want to get your own practice using the calculator and calculating these logarithms. Okay, so here's our last problem, number 18, that we're going to do. It says for a sound with intensity I, intensity for I, in watts per square meter, the loudness L of I of the sound in decibels is given by the function, and it's this log function here, as you can see, I over I of 0, where I of 0 is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. The intensity of the sound of a certain children's television show is half the intensity of the adult show that is on before it. By how many decimals does the loudness decrease? So first of all, you want to see that the children's television show is half as loud as the adult show. And so to be able to figure out, okay, the difference between the loudness, it says by how many decimals does the loudness decrease? So we would want to basically figure out, okay, the loudness of the adult show minus the loudness of the children's show, and that would give us how much the loudness decreased. So for the adult show, we're going to use this function right up here. So the adult show is going to be the loudness intensity part, just the L of the I, whereas the children's one is half of that intensity. That's what it's saying there. The show is half the intensity. So we're going to say half times the intensity there of that. And so we're using this for intensity of loudness. And so we're going to say, okay, for the loudness of the adult one, it's just what this formula is, but for the children's one, it's going to be half the intensity, 1/2 I, which the I is on top of the fraction up there, so it's going to be 1/2 I on that one. Everything else is the same except the 1/2 is going to be up here with I. So now we're going to use those properties. If we have a 10 outside of both of these, what we could do is we could factor out the 10. That's just a factoring property. We could factor out 10, and now we have the 10 on the outside of the parentheses, and we have these two now, which we can put together because we have the subtraction. We also see a 1/2 here. So the 1/2 right here is actually going to be going in front of this logarithm. So it's going to end up doing this right here. It's actually going to be splitting this apart. So this is a product on the top here. So we can use the product property here, kind of expanding this out So we're going to expand this with 1/2 in I, so log basically of the half right there, and then log of our I over I of 0. And where that's the product property is a plus, and you see I did put a plus here, but what I need to do is I need to cross that out. Because of the minus sign here, it's going to affect both of these, changing the sign. So that's why I'm putting this kind of in a parenthesis here to show we got to distribute the negative that's in front of this log to both of these, making this also a minus sign here. Because the product makes this a plus, but because of the minus sign in front of the whole log, we actually have to multiply by the negative, changing that back to a minus. And so now we can see as I crossed out these two where it's are opposites of each other. So log I over I of 0, and this is minus log I of 0. Those two are opposites of each other that would cross each other out. And all that's left is now this negative log of a half. And so now we have 10 times a negative log of a half. And so what we can do there is kind of figure out what that is. So I'm going to just multiply 10 into that. So now it's negative 10 times log of a half. And as we do that, we could figure out what log of 1/2 is on the calculator. Right? We could just do that real quick. So I could put my 1/2, or actually I'll just put 0.5 maybe. So 0.5 in there, and then hit the log button, and there's that number right there. So you can see there it is. That's how I got that number. And then just times by negative 10. So if I times it by negative 10, I can even do that on the calculator if I want to. It's going to become a positive though. Negative times negative is positive. When I times it by negative 10, it's just going to become 3.01. And so that's the difference of the loudness. So it decreased by that many decibels. So it decreased about 3 decibels in loudness for the children's television show. Alright, so that concludes our lesson here on 6.5. You should be ready for the assignment for 6.5, and go on to that and then turn that in when you're done. Alright, I'll see you in class.